Today we're going to be talking about section 6.6, which is on solving radical equations. Our goal is to simply do that, is to solve radical equations. Now, a radical equation is an equation with radicals that has variables in their radicands. Okay, so it has a radicand. Most likely we're going to be looking at square roots and cube roots, but the same process is going to be the same for all radical equations. So when solving radical equations, we want to follow these steps. First of all, you always want to get the radical on a side of the equation by itself. Just like when we solve the equation 3x plus 2 equals 7, you want to get the x by itself. So you'd subtract the 2, divide by 3, now you have the x by itself. That's the same thing we're going to do for the radicals. We want to get the radical by itself. Then 2, you're going to raise each side of the equation to the same power to eliminate that radical and obtain a linear, quadratic, or other type of polynomial equation, and then solve the polynomial equation using the techniques that you've already learned in the variety of chapters. And then you're always going to want to check your solution. Plug it back in to make sure that it works. So when we look at example 1, our goal is to solve this. Well, we have the square root of 5x minus 9. That's on a side by itself, so that radical is isolated. So what we're going to do is we're going to square both sides. So if we do that, now we get 5x minus 9, because the square root and the square cancel each other out. 11 squared is 121. Now we have a linear equation. You've solved hundreds and hundreds of problems just like this, so you solve it for x. 5x equals 30. And then you divide by 5, you get x equals 26. All right, so what you're going to do is you're going to want to check that. You're going to want to plug it in, make sure that it works. Well, remember, here's your original equation. So 5 times 26 is 130. 130 minus 9 is 121. The square root of 121 equals 11. So it does work. Here is your answer. So let's jump down to the guided practice. Go ahead and do those 3 problems. Hit pause on the video, and then you can hit play when you are ready to resume. And here are the answer to the 3 guided practice questions. Now again, remember to plug those numbers in to check if the solutions work for your original equations. And in this case, all 3 of them do. So we're going to jump down to example 2. And it says solve a radical equation given a function. It says if an 8-foot ladder is leaned against the wall, the height of the ladder along the wall is given by that function, where x is the distance along the floor from the base of the ladder to the wall. Estimate the distance that the ladder should be placed from the wall in order for the ladder to reach 7 feet from the floor. So here's our wall. Ladder's pushed up against the wall. It says the ladder, the height of the wall is going to be here, and the distance from the ladder is there. So we're going to plug in the numbers. Oh, we'll call that x because that's what they said there. Well, we're going to look at how to set this up. So we know that we want it to be 7 feet off the floor. So that means that 7 is going to have to equal our radical equation. So now we just solve it. Square both sides. So we get 49 equals 64 minus x squared. Simplify that. We're going to get negative 15 equals negative x squared. So obviously x squared equals 15. And then we take the square root of both sides. Remember, when you do the square root, you're going to have to get a plus or minus. So x equals, and since this is a real life situation, we're going to get the decimal value of it. So it's 3.87. That's plus or minus. However, obviously, the distance from the wall is not going to be negative 3.87. So we'll say the ladder should be 3.9 feet approximately from the wall. So that's what we should have for that one. Examples 3 and examples 4 now give us equations with rational exponents rather than radicals. So we're going to do the exact same thing. Again, example 3, we got to divide by 7. So now we get x to the 3/5 equals 8. Well, here's where the difference occurs. If this was the 5th root of x, I would take it to the 5th power. So that the 5th root and the 5th power would cancel out. We're going to do the same thing here. We want something to cancel out. So we're going to raise this and this one to the same power. Well, what is that power going to be? Well, if this is 3/5, if I raise it to the 5/3, remember this is a power to a power rule, so we multiply those exponents, which means 3 times 5 is 15 and 5 times 3 is 15, so that's going to give us 1. Well, I then also have to raise that to the same side, so now I'm going to have x equals 8 to the 5/3. And again, if you want to, if it makes it easier to see, you can write it in this form and do it this way. Well, the 3rd root of 8 is 2, and 2 to the 5th power is 32. So there's your answer, and it is D, 32. In example 4, we're doing the same thing. Instead of a radical that we have to isolate this time, we have to isolate the term with the rational exponent. So we're going to add the 9 here. So it's going to be x minus 4 to the 2/3 power equals 25. So now we have to raise this. Do this in a different color. We're going to raise this. It was to the 2/3, so we're going to raise it to the 3/2. And so now we're going to get x minus 4, because the 2/3 and the 3/2 will cancel out. They multiply to give you 1. Square root of 5 is, or square root of 25 is 5. 5 to the 3rd is 125. And so x equals 129. Okay, and once again, you're going to want to put that in to see if it works. We should always plug them in to see if they work. So if we put it back into your original equation, 129 minus 5 is 125. The 3rd root of 125 is 5. 5 squared is 25, and 25 minus 9 is 16. So we have that 16 equals 16. So we know that this is, in fact, a solution to the problem. All right, so let's jump down to the guided practice. We're going to solve equations. I will do all 6 of these. You can pick however many of them you want if you want to do a couple of those. But go ahead and pause the video, and you can hit play when you're ready to resume. And there are the answers to those 6 guided practice questions. Notice we have to raise it to the reciprocal of whatever power it's being raised to. And that way when we multiply those two, we get 1. And that eliminates the rational expression from the side of the equation with the variable on it. So then we can solve it. All right, the next thing we're going to talk about is what happens if I have to raise each side of the equation to the same power may produce extraneous solutions. Now, all of the ones that we've checked so far, we've plugged them in, they've all worked, they've all been solutions. Great. Now, that might not necessarily be the case. So when you use this procedure, you should always check the apparent solutions in the original equations. So now we're going to start seeing some that are solutions to the answer that we get, but are not really answers to the original equation. So it's an extraneous solution. It's an extra. It's not really a solution to the problem, but we get it as an answer because of the way that we have to do the problem. So let's look at example 5. We're going to do the same thing. Everything is exactly the same. So we're going to take this and we have a square root, so obviously we're going to square both sides. So this is going to be x minus 6, and then the right's going to be x squared minus 16x plus 64. Remember, this really means x minus 8 times x minus 8. So you have to FOIL that part of the problem. Okay, don't forget to do that. Many of you are going to forget to do that, and it's going to be not correct. You're going to miss that middle term because we have to FOIL those. So now we put everything in one side. So we're going to have 0 here. We're going to have x squared. We're going to subtract that x to this side, so it's going to be negative 17x. We're going to add 6 over there, so that's going to be our 70. And so now we have a quadratic equation. And when we have a quadratic equation, you should have plenty of experience solving these now. So we're going to factor them. If it doesn't factor, you can use the quadratic formula. So they're both negative signs. Factors of 70, we're going to go 7 and 10. Does that work? That gives me negative 10x for the outsides, negative 7x for the insides. It's negative 17x. That's what we want. So that is factored correctly. Now we have to solve it. So here, x equals 7, and here, x equals 10. So those are the two solutions. However, we have to plug it back in to make sure that those are solutions to our original equation. If they're not, then they're really not solutions. So let's go back up here and plug those numbers in. Let's put in 7. 7 minus 6 is 1. Square root of 1 is 1. So the left side is 1. 7 minus 8 is negative 1. Does 1 equal negative 1? Absolutely not. This is not a solution. That's an extraneous solution. It's not a solution to our original equation. Let's check 10. 10 minus 6 is 4. Square root of 4 is 2. 10 minus 8 is also 2. Does 2 equal 2? Yes. So this one is a solution to your original problem. Now the thing you have to make sure to double check is you have to plug both of these in. Okay? Sometimes they'll both be solutions. Sometimes one of them may be a solution. Sometimes none of them might be a solution, or none of them will be solutions. So we just have to make sure to take our answers and plug it back in to make sure that it is actually a solution. All right, next, we're going to look at example 6, and this one has 2 radicals in it. So when an equation contains 2 radicals, you may need to square each side twice in order to eliminate both radicals. So what we're going to do is isolate one of the radicals. So the nice thing in this equation is that the left side is already isolated. So what we're going to do is we're going to square both sides. The reason we have to isolate a radical is now when we square that one, it's just going to be x plus 6. Okay, so then we also have to square this side. Well, remember, again, this is going to be a foiling problem. I'm just going to write it out here over on the side, and let's FOIL this. So if we take the first, square root of 11 minus x times the square root of 11 minus x is 11 minus x. Okay, so that's our outside. Now, our insides, or sorry, those are our firsts. Our outsides for the FOIL is going to be negative 3 times the square root of 11 minus x. Our insides is going to give us the same thing. And then our last is going to give us plus 9. So now what we're going to do is simplify this. So really what we just did was FOIL it. FOIL the right side. So we're going to have, and I'm just going to leave this over here for right now, x plus 6, and I'm going to simplify everything over here. I have 11 and a plus 9, so that's going to give me 20 minus x, and then minus 6 of the 11 minus x. That's in the square root. So let's move the 20 and the negative x over. So that's going to give us 2x minus 14 equals negative 6 square root of 11 minus x. So now we're going to have to divide both sides by negative 6 because now our goal is to isolate this radical over on the right side. Again, that's the radical we have. That's what we want to isolate. So we're going to divide both sides by negative 6. So if we take that out, we're going to have x, divide all of this by 2 minus 7 over negative 3 equals square root of 11 minus x. Right. So now what we are going to do, we have the radical isolated. So what we're going to have to do is square both sides. So once again, if we square the left side, we're going to have to take that 2 through to everything in there. Well, that x minus 7 has to be squared, so you're going to have to FOIL that. So that's going to be x squared minus 14x plus 49 over negative 3. Oh, sorry, negative 3 squared is 9. Just going to have to FOIL that one. And then on the right side, we're going to have 11 minus x. Now, I don't want to have that fraction there, so I'm going to multiply both sides by 9. So I'm going to get x squared minus 14x plus 49 equals 99 minus 9x. If we use the distributive property, get rid of that 9. And so now let's put everything on the same side. And so we're going to have x squared. Move the negative 9x over. That's going to be a plus 9x, so that gives us 5x. 49 minus 99 is going to give us negative 50 equals 0. And so now, once again, we have a quadratic equation, and we're going to factor it. So factors of x squared are x and x. Factors of 50 are 1 and 50, 2 and 25, 5 and 10. So it looks like 5 and 10 is going to be the one that works. Sign is negative on the 50. That means we have one of each. So this one has to be positive. This one has to be negative. That's going to give us 10x and negative 5x, which is 5x. So we're good there. So x equals 5 and x equals negative 10. So now what we're going to have to do, go to our original equation, plug them in to see if they work. So we're going to check 5 and negative 10. So let's erase this up here so we can see this. So we're going to plug it in. 5 plus 6 is 30. So, 5 plus 6 is 11. So we have the square root of 11. And 11 minus 5 is 6. So we have the square root of 6 minus 3. So if we plug that in, all right, well, we need to go back and change something. We found a mistake here. So if we look at this, when we subtracted our 9x, this should have been a negative 5x. So let's make that switch. This should be a negative 5x, which is going to change. We need to have a negative 5x. So this, we have to have still one sign of each. And that means the 10 is going to be negative, and the 5 is going to be positive. So x is going to equal negative 5, and x is going to equal positive 10. So now let's check those to make sure that they work. So again, now let's take those back to our original ones. So negative 5 plus 6 is 1. The square root of 1 is 1. 11 plus 5 is 16. The square root of 16 is 4. 4 minus 3 is 1. And so this one does work. Now we'll put in 10. 10 plus 16 is, 10 plus 6 is 16. Square root of 16 is 4. 11 minus 10 is 1. The square root of 1 is 1. 1 minus 3 is negative 2. That obviously is not true. This is not a solution. So 10 is not a solution to the problem. The only solution to this problem is x equals negative 5. So there are 4 guided practice questions here. You can go ahead and you can do whichever one of those you want. I'll do all 4 again, but go ahead and pause video and you can hit play when you are ready. And here are the answers to the 4 guided practice questions. So notice in number 11 we had an extraneous solution. In number 12, both of those solutions ended up being true. And 13 and 14, we only ended up with one solution. And when we plug those in, both of those work in the problem. So section 6.6 is the last section in this chapter, and it's on solving radical equations. So we solve these by doing the same things we do with all of the equations we solve. We want to first isolate the radical expression and then use what we know about radical expressions, the inverse operations. If we have the square root, we're going to take the square so that they cancel out. If it's a rational exponent, we're going to multiply it by the reciprocal of that exponent so that they cancel out. So we're using the methods that we've talked about this far to solve any type of these radical equations. So here is the homework set for section 6.6.